Welcome to this lecture on web service composition. Today we are going to see how you can integrate the web services that you saw how to develop in the last classes so far. Let's see the context of this lecture. We are talking about SOAP and WSTL web services. So we are, in this case, in the next two videos, we are not going to talk about RESTful web services. We specifically look into the case of SOAP and WSTL web services, meaning web services that have essentially four types of operations, that may have four types of operations. We have the classical request response and the notification messages. Then we may have a solicit response and the event messages. The first two, meaning the request response and the solicit response operations, they are the traditional synchronous operations, while the notification and the event are asynchronous messages. So what does it mean to compose web services now? So what do we want to understand in this class? So essentially we want to understand how to develop something new out of a set of given web services. For example, in this case here, we have four web services. They are just randomly chosen. We have a book order web service, we have a payment service, we have a warehouse service, and we have a last service, a shipment service. So you can imagine that given these services, we can, for example, invent a new kind of application or a new kind of web service again that is like a book order management service. And the question we want to answer, at least partly, in this and in the next two videos is essentially how to develop the composition logic inside this new service that we want to develop, so as to bring together and glue together these services that actually have been developed, at least typically have been developed, without knowing about each other and without thinking about being integrated into something new. So why would we want to do this? There are some benefits, and it's important to briefly recall these benefits. First of all, composite services, they add value. So we saw, for example, four web services, and these four web services, they already deliver some service to their clients if taken individually. But if we integrate them, we can develop a whole new service or application which provides for the management of a whole process, not only of an individual functionality provided by a service. This new process adds value to the customer, and the customer might be able to or might be willing to pay for this added value. Then, talking about web services are particularly suitable to develop integrations or applications and services that span different or across boundaries. So it's very easy to integrate functionality from different companies, from different realities, from different institutions. It's easy to do this over the internet, and web service composition allows you to do so very easily. Then, from a technical point of view, composing web services essentially means reusing existing application logics. So reusing logic means reducing cost, and this is very important in software development. Then reusing also means that we reuse application logic encapsulated into web services that has been tested over and over again by not only by us but also by other users, by other clients of the same service. So we have a well-tested and a robust set of web services we can rely on. This increases the quality of our product. Then web services or composite web services, or the application we develop, we can publish it again as a web service itself. So not only do we reuse web services that are already there, if we compose them into a new web service, we can publish it again and allow others to reuse the whole process, the whole composition we developed, starting from the web services. And then, given the standards and the, by now, let's say 10 years of experience in web service development, there we have good and powerful abstractions for the development, for example, of visual development tools or of other aids for developers. So this, of course, increases then the development time of a composite application. And finally, again, thanks to the availability of standards and to the good experience so far with the web service technology, there's a huge potential for automation in the context of web services. We will see this perhaps as one of the very advanced aspects in the end of this lecture. So, let's now try to understand more deeply or in more detail what it really means to do an integration of web services or composition. Let's again take the 4 web services of before. We have a book order service, the warehouse, the payment, and the shipment service. So the book order service, we can imagine it as the service that is the back end of a web application where customers can browse books and where they can choose the books they want to buy. The payment service, just imagine your whatever common credit card company providing this payment service. It could be a Visa or MasterCard payment service. The warehouse, this is very likely our own internal web service that provides the warehouse availability information, and it orders books if they are not available when we want to order them, and so on. And finally, the shipment service, this could be just UPS or some external shipment company or carrier that we involve in the delivery of the books. Okay, so if we now want to implement this book order management application, the first step we want to do, or we have to do, is essentially to wait for the order coming from the book order service. And in response to an incoming order, we have to invoke the warehouse service and to check whether the books that the customer wants to buy, whether they are in stock or not. So this is called a composition activity, and there are then operation invocations involved. So from one side, the book order service invokes our composition logic, and then in response we have to invoke the warehouse service. That is, we need to be able to interact with these web services. But not only this, invoking a service essentially means providing inputs and then processing outputs again. The inputs in this case are, for example, the list of books the customer would like to buy, and then some information about the customer himself. Then, in response to this input, we forward the list of books to the warehouse. Then the warehouse service checks whether the books are already in stock or not, and provides us with a book availability, checklist or similar. Based on this checklist, what do we do when we want to integrate these services and we want to provide a service again? We need to decide if we have all the books in stock, we can just progress. If instead we don't have all the books, then we might have to wait again. So this is called a decision point, meaning we have to decide what to do next depending on some condition that happens during the composition process. So actually not during the composition process, but rather during the runtime of the composition. So in this case, if not all books are there, for example, we might have to wait for the confirmation from the warehouse that will notify us as soon as the books that were not in stock have arrived, and then we can progress with the processing of our composite service. If instead all books are already available, we can go on and we can authenticate with the payment service, and we can start processing the payment. Apparently, this sounds like a very simple invocation of a web service or a common invocation of a web service. In practice, especially with payment services, this is not so easy, and the authentication typically requires not just one step but several steps of interaction with the service. This is commonly called a business protocol, meaning the service, the payment service, tells us the order of the message exchanges we have to follow in order to correctly interact with the service. In this case, for example, let me switch on the pen. We first send an authentication request to the payment service, which in response sends us an access token. Then, only if we have the access token, we can invoke the actual payment operation of the payment service, where we send the amount of money that we need to pay and some customer information with the credit card details for the payment. Then we know from the business protocol of the payment service that once the payment is processed, this is an asynchronous operation. Once the payment is processed, it will notify us again via a notification that will be directed to our composition, which means again we have to wait for the payment confirmation, and then we can start processing the order shipment, which means just invoking again the shipment service, sending the shipment addresses, and this essentially concludes our composition. Okay, so let me summarize the key composition concerns we have seen in this very simple example. First of all, service access. So composing services means being able to access services first of all. Accessing means invoking them, so talking to the operations of the service. And this requires then the management of some very low-level details such as the HTTP operations, SOAP messaging, XML serialization and deserialization. Then we have the management of synchronous and asynchronous service invocation. Just the synchronous ones, they give immediately a feedback, and the asynchronous ones, we have to wait for the feedback by the service in a non-blocking fashion, for example, and similar. Next, as we have seen, data flow. So we need to be able to pass data among the services. We compose them, so the idea is that we integrate services that provide some that provides some data that we need in our own composition, and then that also the other services need. Because if we integrate them, then perhaps they can deliver their functionality only by passing data from one service to the other. And doing so requires, for example, invoking several web services in a row, buffering temporarily the feedbacks, the outputs of these web services, integrating these data, and then forwarding it to another web service. Of course, integrating, forwarding, and so on requires very likely also the transformation of data. So the web services, they were developed independently of each other. As I said before, they were not developed by thinking about any specific integration yet. So each of the services potentially just adopts different data formats, different data structures, and integrating them means mediating between these data formats. And we might have, we might have to split data, to merge data, to transform data. But transforming may also mean writing scripts and not just simple data mapping parameter value pairs. So data mapping can be a very complex, complex task in the composition process, but it is definitely one of the necessary tasks that needs to be mastered. Then, finally, it's not really finally. Next, let's say, there's the control flow. So the control flow is essentially the order of the composition activities in our composition. Why is the order so important? So we cannot just randomly invoke services. We have seen that some services, they have a data dependency. Not all services have a data dependency, but in general, we want to achieve our goal, in our case, the book order management process. And this goal involves a given set of steps, and the control flow decides which service to invoke when, passing which data to which service, and so on. And then, as we have seen in the example, deciding this order of invocation may also involve the evaluation of decisions. The decision in the example was about whether the books were available or not in the warehouse, and it was based on the output that we got from the warehouse web service. But in general, these decisions may be based on any kind of data that is available at runtime. And decisions are one of the key aspects in deciding the control flow. Now, finally, we have seen that there may be business protocols. So the web services may come with their business protocol that we simply have to respect. If we don't respect, we as a client of the services, if we don't respect these business protocols, we are just not able to interact with the service correctly. So just to state it a bit clearly, or to define it, a business protocol of a web service tells in which order the operations of the service must be invoked so as to correctly interact with it. So, and as said, the control flow of our composite application must comply with this. So this leads then very likely or obviously to the need of correlation. So what is correlation? Imagine that we have our composition ready, and we run 10 instances of this correlation, of this composition on our web server. And then during runtime, these compositions, they invoke external web services. Imagine now we invoke 10 different web services, for example, on the internet. So we have 10 different so-called conversations going on in parallel. Imagine now that all the external 10 services, they have to send us back a notification at some point in time. What do we do? How do we understand which of the notifications coming to our web server belongs to which of the compositions running on our web server? This is done by so-called correlation information that must be added to the messages that go in and out of our composition. So, maybe one precision before going on. We talk about web service composition, but there are two, at least we can distinguish two conceptually distinct types of web services. First, we have business services, and then we have middleware services. So the business services, they are essentially the services that we are interested in, the services that we really want to compose. And as we have seen before, so we have a composite application that has either that integrates either some local services that we developed ourselves, or that integrates services coming from the internet. But then, in order to actually execute the interaction with these services, there is some middleware that is there and that provides services. So the middleware services, they are simply services that sit between the services that we actually want to integrate, and they provide some cross-cutting features. So which could be these features? We have, for example, reliable messaging services, we have the orchestration services, maybe transaction processing services, or we have, of course, simply discovery services on the internet in order to find other web services, or some security services. So just to be clear, in this lecture and in the next videos, we are not interested in these middleware services yet. We only look at how to integrate business services. Then, one other comment, coding versus composing. There is always this, this ambiguity. Essentially, you can code whatever composition you are interested in. You can always code it with the programming language of your preference. This can be JavaScript, Python, C++, Java, whatever you want. When we talk about composing instead, we want to emphasize perhaps the nature of the composite, let's say the composite nature of a composite service or application. The fact that it is developed starting from a set of web services that are already there and that are simply reused as is. And then there are some very specific composition-specific abstractions, and also tools have been developed that are specifically tailored to the needs of composition. Finally, last slide of this introduction. Composition, what does it mean in practical terms now? So, over the last years, two approaches have emerged. The first one is called orchestration, the second one is called choreography. These will be the subject of the next two videos, and that's it for now with the introduction. I hope you enjoyed it, I hope you got stimulated, and I really hope you want to know more and you will be back with the next two videos.